going to consider density, which is always a ratio of two units. The definition for density is down here. Density is always reported as mass divided by volume. In chemistry, we're going to see that the mass is almost always in grams, and the volume is going to be in milliliters or cubic centimeter. It just so happens that 1 milliliter is exactly equal to 1 cubic centimeter. And we may see this in the medical field. A cubic centimeter is written as a cc. So if you get a shot, it may be so many cc's. And so a cubic centimeter is a centimeter by a centimeter by a centimeter. We really don't need to worry so much about that. But the volume would be a length and a width and a height measurement. So if we had 1 centimeter by 1 centimeter by a 1 centimeter cube, if we solve for the volume and take the length times width times height, 1 times 1 times 1 is 1, and centimeter times centimeter times centimeter is where we get centimeter cubed. It's more common to use the unit milliliter. In lab, we're going to measure out milliliters with a measuring cup, and so a milliliter and a cubic centimeter may be used interchangeably, but density is always mass divided by volume. And at the top of the page, I've written that we could think of a common measurement that we use 2 units in, and that would be, we could say pounds per gallon. We could also talk about mileage, gas mileage, and that would be miles per gallon, for example. So if you get 25 miles per gallon, this denominator is understood to be a 1. So density is going to most often be used in chemistry as a unit conversion. It's going to allow us to convert from volume to mass or from mass to volume. The density of water is 1 gram per milliliter, or again, because milliliters and cubic centimeters can be used interchangeably, we could write that as 1 gram per cubic centimeter. So if we write 1 gram in the numerator per 1 milliliter in the denominator, this is the most common way that we would report the density. This slash is useful when we're typing, but it's most useful to actually show that slash as a line so that we visibly have a distinct numerator and a distinct denominator. Ethanol, which is a fuel or an alcohol, has a different density than water. So the density of ethanol is 0.785 grams per milliliter, and again, it's understood that that means per 1 milliliter. Okay. So if we look at an algebraic definition of density, density could be represented by D. M in this case is mass, and V is volume. A common way to use the density is to solve for the mass. So if we take this definition and we multiply both sides of the equation by volume, then the mass unit is all by itself, so mass equals density times volume. We can also rearrange this equation for density and solve for volume. So if we divide both sides of this equation by D, then the D's cancel and volume is equal to mass divided by density. Because we are going to cancel units to solve problems, we really don't need to memorize all this. For example, if I want to solve for the mass of 25 milliliters of ethanol, I'm going to use the density, and here the density is given, so that's kind of a hint. But if I'm looking for mass, I'm going to put this unit gram in the numerator. So if I just rewrite that number, so on here I have 0.789, here 0.785, so I think I've got a typo here. So we'll put 0.789 grams, and this slash is really a division sign. So 0.789 grams per milliliter, I'm going to write the 1 here. And if I'm looking for mass, I've got the gram unit in the numerator, and the milliliter unit is not a mass unit. So I can cancel that. I can just multiply this, and I can put a milliliter unit in the numerator, just to force that to cancel. And then I look here, I'm given a volume. My volume is in milliliters, so if I write this number here, 25.0 milliliters, again the density unit milliliter cancels with the volume unit that was given, and this tells me that I'm going to multiply 0.789 by 25. We will also report our answer to 3 significant figures because we've got 3 significant figures in this measurement, and our density is also given to 3 significant figures. So 0.789 times 25 ends up being 19.725. So we will round this to 19.7. The only unit left is a gram. So I solved this just by units. If we memorize the definition for density in this form, mass is always density times the volume. This value given was the density, and we multiplied it by this value given, which is a volume. Okay. This next problem we solve the same way. We're going to use the density of ethanol, and in this case we're still looking for the mass, and our volume is given in liters. So if we take 0.789 grams per 1 milliliter, and we try to multiply that by 1.5 liters, we're going to see that we have a gram and a milliliter and a liter, and that nothing cancels. So we could still take density times volume, and then we can convert milliliters to liters. We could do this with the metric number line, or remember that 1 liter is the same as 1,000 milliliters. We could have also converted 1.5 liters into milliliters by moving the decimal 3 places to the right. So this is equal to 1,500 milliliters. And we can see from the math below that we're going to take 1.5 and multiply it by 1,000, which would give us 1,500. So there's oftentimes a lot of different ways to solve a problem, and the solutions manual may not look exactly like the way you've done it, but when all the units cancel, in this case a gram is left over, we know that we're setting the problem up correctly because a gram is a unit for mass. So here we're going to take 0.789 times 1.5 times 1,000. And when we do that, we get 1,183.5. If we look back at our measurement that has 2 significant figures, we should round 1183.5 to 2 significant figures, so this would turn into 1,200 grams.